Hey everybody, can you hear me? Awesome. So thanks for the introduction. Again, my name's Laura, and I'm a software developer at LlamaZOO Interactive, which is over in Victoria. LlamaZOO is a 3D visualization company, and as you just heard, that means we're creating three-dimensional experiences to help people better understand their data and the world around them. Our company has a strong background in gaming. The gaming industry is one which is constantly pushing towards creating bigger and better, faster, stronger, more powerful experiences, but with entertainment in mind. Over at LlamaZOO, we're doing very similar processes, but we're actually coming up with a different end result. So the LlamaZOO mission is to create a 3D platform for visualizing 3D data of all kinds for a desktop, mobile, VR, AR, and MR to help everyone experience their 3D data. So what does this all mean? Virtual reality to start, or VR, means that you have a completely different virtual environment. You put on a headset, and the world around you changes. Instead of seeing the people beside you, you see a completely new world. Everything inside that world is computer generated. AR, or augmented reality, is different. With this version, you have the real world still in front of you, but you have a digital overlay over your face. So you might see the building with some location markers on your screen. Separate, but it helps to further develop the information that you're seeing. And finally, MR, or merged reality, is a combination of the two. So with this, you have your physical world, but then you also have a digital component, and these two components can interact with one another. One example is placing a health meter on your friend's head, and you watch them walk around, and the health meter will walk around with them and change depending on how they're feeling. So the physical world and the digital world can now interact with one another. At LlamaZOO, we're using these technologies to solve real-world problems. With any great software, the first step is to identify what problem we want to solve. When LlamaZOO started, the problem that we identified was with veterinary education. So we were seeing vet students using traditional media, outdated sources like books, to learn about 3D software, or 3D content, rather. And there was a growing demand from millennials and new students to have a digital resource to learn these subjects, because the world was changing to be more digital. They wanted their school to reflect that. And so with so much to learn and so little time, could there be a better solution for this process? At LlamaZOO, we decided the answer was yes, and we then developed the first ever medically accurate virtual canine cadaver. It's being used across the world, and it's very helpful for interacting with anatomy, and I'll tell you a little bit more about that as we go on. Right, so it's being used by over 5,000 students worldwide across what has now grown to 80 schools and 120 countries. If you're a veterinary student, the very first animal that you learn in your degree is actually the dog. So when students are in their first year, they're able to use our software, JABC VR, to help them understand this new subject material when it might seem the most overwhelming. And it's not just for students. Veterinary practitioners are using JABC VR as well to help engage with their patients' owners to help them understand what's going on with their canine friends. So that's all really cool. How did we do it? How did we go from the first X-ray of an animal, the very first piece of 3D content, to a final, fully fledged virtual reality experience? The answer, like you've heard from many different speakers here, all starts with the team. So we have a team of very diverse teammates who have different backgrounds, different skill sets that all work together to create this end product. I'm going to explain 3 of the roles that we have in our team today. Now, the first is the 3D artists. They create that content that you see on the screen or in your virtual world. The second are the developers. So I'm one of those. And we create actually how that content works inside of the application. And lastly, I'm going to talk a little bit about the UI and UX designers who create how you will interact with our content. OK, so let's start with the 3D artists. Now, this part of our team first inspects that 3D X-ray that we get, and they create a 3D mesh, as you can see above. This is essentially a wire model, which is created with 3D software, going from the data source to a final output that we can then manipulate with the computer. They also create what are called materials, which are hand-painted textures, and they have some shine information and roughness information, which are then applied to those models above to get something like what you see below that eyeball there. So that's all well and fine, but because we're creating educational software, we need to make sure that it's perfectly accurate so that you can trust the software that you're using to actually help you along with your studies. So this proved to be a little bit of an issue for us because we were relying on X-rays, but as you may imagine, pet owners don't typically take their healthy dogs in to get an X-ray. So there's a really small sample set here. Usually it's more of a reactionary measure. Their dog is sick, it has a broken leg, they take it in then. So in order to get healthy X-rays that we could use for our creation of Jetson VR, our software, our 3D artists actually had really long Skype calls with professors and anatomists, and we partnered with universities to make sure that we were hearing from the experts who were teaching the students already exactly how this model should look in our application. So they were able to answer questions like, exactly how glossy should this part of the brain look when we're dissecting the dog? Or those toes on the left paw, should they be this shade of beige or this shade of beige? Really specific details just like this. And all these calls were super valuable for our team to create the software that we have today. OK, so the next role that I'd like to talk about are the developers. So I'm a developer. We create the actual functionality for the application. Where the 3D artists create the thing, we create how the thing works. We write code, we think logically, all this type of stuff. Some code example is up there. I'm not sure if you write code in school now, but hopefully you do, and hopefully you're excited about seeing all the little numbers and quotation marks in the top corner there. Just as excited as I am. Yeah, so we create all the functionality by mapping. If you click on an object, do you want it to highlight? That all has to be written by code. If you move an object, that all has to be written by code, things like that. We also tie in some metadata. So an object is not just a 3D object like it is in the real world. Every object actually stores metadata as well, so information about that specific item, because this is a tool used for education. You want to learn about it. We also create the functionality for taking your own notes in the application and even drawing pictures. Now, because I'm here today, I'm going to tell you a little bit about me and how I got into the role of a developer at LlamaZOO. I actually have a computer science and physics degree, which I got at UVic, and I graduated just last year. And I've been working at LlamaZOO for about a year now. So with my computer science background, I was taught about software development, was taught how to think logically, how to problem solve, how to write code, but also how to learn new languages that I'll need to write code with later on. And really just how machines think. Because as a computer developer, as a software developer, you need to understand what the computer needs in order for you to get the output that you desire. And so with the physics background, that's a little more uncommon. We actually find it incredibly helpful at LlamaZOO because when you're creating a virtual reality experience, you want the world around you to feel believable. So we need to know things like, how does gravity work? How do different objects collide with each other? How does light reflect off of glass in your world? How do the objects look through a window as opposed to just right in front of you? All these are examples of physics concepts that are mimicked in a virtual reality environment. And the third role I'd like to talk to you about today are the user interface and user experience developers or designers. So they create exactly the look, the feel, how everything in the application interacts. And as you can see are a couple of examples of what our UI and UX designers have actually created. So on the left there is a virtual reality world. You've got a hanging menu that will actually rotate when you walk around. And it'll follow you so that you always have that information handy. You've got a navigation menu on the bottom there, below the dog. And that's even more handy information that you want up front. That circle also follows you around as you move. And you've got another panel on the right that's hanging as well. On the right picture, you see a more classic application. So this is our desktop and mobile version of the app. And you can see that there's a top navigation bar there. This you're very used to seeing on all of your mobile applications, on desktop web browsers and things like that. And then some panels and menus on the left and right. And in the middle, you have what's called a radial menu. So this will pop up every time you select every single one of those veins, arteries, bones in the application. And it'll give you the options that you require for that one specific object. So working as a UI developer or designer, you're going to be creating wire meshes or wireframes. These are what tell us developers what exactly to code, where to put it, what every click does, things like that. Now, at LlamaZOO, we're doing different types of development. So we're doing desktop and mobile, but we're also doing VR, MR, and AR, which means the UI designers have a couple of different tasks at hand. With desktop and mobile, the world actually contains a couple of, or a fair amount actually, of standards that are expected to be applied in these applications so that users like you can pick up the iPad and just use it and know exactly how it'll work because it's how all your other apps work. You know, the search bar is on the top right. You know that right-clicking is going to do something than left-clicking. Keyboard shortcuts, things like that. However, in VR, virtual reality, or AR and MR, these technologies are so much more new than the old desktop and mobile ones, which means these standards that we're able to apply on desktop and mobile don't actually exist yet. The world has not yet decided which VR controller should do what, which button should do what. You know, is it better to have a menu far away from you up front on your lens, in the ceiling, everything like that, what a highlighted button should look like. So with every application that we release, the UI designers are actually creating these standards for the world. And these three roles, as well as a few others at our company, bring us to the final result. So our team has created Jetson VR, which started on desktop and mobile, as I said before. And it's now developed into this final, well, nothing's ever final. It's developed into the current virtual reality experience. As with every software company, we're always developing and improving on our product. And so there's a lot of thinking that goes into play about making things that are able to develop as the requirements change over time. OK, so why is this a game changer? Why is virtual reality helpful for learning about 3D content? The answer, in a nutshell, is because of how engaging it is. So I, for one, know that I learn way better when I actually physically do something than when I'm just told about a topic or when I read it. Even better than when I say it out loud. So if I'm actually playing with a model, building something, moving something around, the level of engagement and the amount that I'll remember a subject increases by far. Now, virtual reality allows you to do these incredible things without actually requiring to purchase all this equipment and buy, you know, an actual live canine cadaver, which is probably going to be difficult to get your hands on, and things like that. But it doesn't just stop at anatomy. So imagine all your other courses. Imagine learning chemistry with cells flying all around you and molecules changing in the air. Imagine learning biology with those structures multiplying and dividing right in front of you. Maybe you're even controlling that division. And also imagine a history lesson. So you could teleport to ancient Egypt and look at the pharaohs and their tombs and explore as if you were there in that time period. So virtual reality is incredibly engaging and useful for all of these different subjects. If there's anything that I haven't mentioned that you're taking in school right now that you think would be helpful for virtual reality, make sure to find myself after the show, and you can let me know, and I'll make sure to write it down. OK, so some of the other organizations that we're working with at LlamaZOO, the other industries, rather, then anatomy include construction, mining and resources, mechanical engineering, heavy industry, so big machines, big complex machines, human anatomy as well, which we get asked about all the time, and molecular biology, like I mentioned before. So all of these different fields are going to have the LlamaZOO platform applied to it, and you can explore these different contents in the 3D virtual reality space and learn even more about them. OK, so that's the last slide that I have for you today, which means that I want to actually get you to experience what I've been talking about this whole time. So can I have a volunteer from the audience who would like to try the virtual reality experience up here? I can't see. Yep, perfect. Someone's already coming down. That's awesome. Yeah. We can only do one today. Sorry. Yep. We'll have time after to try another person, though. So I think you were coming down first. Yep. Come over here. So Charlotte's going to tell you how it all works while we do some polling questions, and then we'll get you to actually put the headset on. Okay. OK, so while the setup is occurring, I want to do a few polling questions to get to know more about you and how you think. OK, so the very first question is, have you ever tried VR before? Yes? 60% yes, wow. OK, 50-50? Awesome. So yeah, it looks like about half of you have. When I was 14, 15, that was definitely not the case. So that's really cool. The next question is, do you think that virtual reality is a good learning tool? Yes, somewhat. Depends. Cool. Very much or depends or winning. I'd be torn between the two of those as well, for sure. OK. Yeah, it definitely depends on what material you're learning. It's especially applicable for 3D content and for real-world experiences, for sure. But I'm sure you can come up with even more creative ways of using it yourselves. So the final question that I have for you is actually, what do you think is the hardest thing about a career in tech? So many of your speakers today have a career in technology. All of us, I think. What do you think is the hardest part about our job? Competitive, OK. You just don't know what you want to do. That's fair. It's totally fair. Simply getting the degree. Yeah, so getting a computer science degree, a software development degree, an engineering degree, all these other technical degrees, maybe that seems really intimidating to you. As someone who completed one of these degrees, I actually found it incredibly rewarding and fun. You're actually getting your hands on new technology, and you're practicing things and learning, as opposed to just reading and writing answers all the time. Which, if that's what you like, that's cool, but it's not how I learn. OK? And not many people think it's a difficult working environment. That's really promising. So maybe that's because as the world is changing, we're seeing so much more technology around us. And you've actually had a bunch of photos in this presentation already about what the environment looks like. So you've seen slides, and in our office, we actually have an arcade machine that we like using, playing virtual reality games in our spare time. So nice, yeah, the working environment is definitely fun, but it might be something that could intimidate you if you didn't know that. Good? OK, awesome. So we're going to finish the polling questions and actually move on to our live demo of Jetson VR. Awesome. So our volunteer here, what's your name? Taurus. He's wearing a headset right now and is holding onto the virtual reality controllers. And everything that Taurus is seeing in his headset, you're witnessing on the screen up here. So we can all see what you see. Cool. All right, so what I want you to do first is actually get a feel for this new world, OK? So you don't see any of us anymore. You see, what do you see? You see a dog. Awesome. And you're inside of a really modern laboratory, and you're going to be able to dissect this dog. So using your controllers in your hands, let's use your right trigger and actually take off the skin of Jetson. There you go. Where'd it go? Yeah? Awesome. Now, this is a serious dissection, people. Come on. We need to now find the brain. Can you dissect the skull, take off components, and see if you can actually get to the brain? OK. Almost there. You can use both hands. OK, so we only have half the brain left, but that's OK. OK, so now that everything is flying around, that's the brain. That's not the brain. No. Now that everything is flying around in the air, what I want you to do is actually take a few steps around this model. So what I was mentioning before about, and just stop here, you're about as far as you can go. Perfect. So you can walk actually around the model, maybe a little bit to your left, a little bit to your right. Cool, and that's about as far as you can go in that direction. We're attached by a cable today. OK, and you can witness that that menu at the bottom is rotating. And you can, exactly, you can stick your head in the dog. You can stick your head in the dog's face. You can try and find the heart as well. Maybe poke your head inside there. Uh-huh. Did you see it? Nice. OK, cool. So one of the other menus we have to use in this virtual reality experience is right below the dog, and you have a list of your systems there. So you can use your laser pointer and actually toggle off some of the systems. So the skin is already gone. That's the integumentary system. That's lying on the floor behind him somewhere. Do you want to toggle off the skeletal system, so the one that has a bone? Yep. And now it's gone. Cool. Toggle off a couple of other ones. OK. Pulmonary, digestive, still there. There goes the digestive. Look up for the audience to see the dog, too. Nice. Cool. So the way that the dog is now, you can see all of these red and blue lights flashing on the dog and streaming along the veins and arteries. This is something that our 3D artists actually talked a lot with anatomists about. We had to determine exactly which direction the blood would flow, what color we should represent it by, things like that. You can keep playing. OK, so what we're going to do now is actually do one of the interactive learning experiences in this application. So Taurus is going to try a learning challenge, or a game. We're going to do the anatomy puzzle. All right, so you're left with the skeleton. You need to fit all of these bones back into the dog. That light there will turn green when you've done it correctly. And it's a time limit, so you have about 1 minute and 20 seconds left. We can share them on. Excellent. So as I was talking about before, I have a physics background. And as you can see right now, physics in this world is a little different than in the world that we live in. These bones, they are affected by gravity, but in a much lower amount. So they actually float in space. And this is really helpful for dissections, because which is different than the real world. You can throw the integrated material system away. You don't have to deal with it. And then with things that you want to deal with, you can have them hovering above the dog. 30 seconds left. Yeah, and remember, you can actually walk around in 3D space. If you want to get closer to something, you just get closer to it. It's intuitive. Awesome. You're doing better than most of our employees did on their first try. Especially me. All right. OK, let's have a hand for our volunteer. Thank you. Yes, sir. OK, so that's everything that we have for you today. Thanks so much for having me again. And look forward to talking to anybody else that's interested in looking at this at a table out there. Thanks.